Okay. So good afternoon, and we're getting started with some proofs on triangle congruence. We've spent the last couple of weeks talking about congruent figures and specifically triangles that are congruent and how we can prove that triangles are congruent when we're not told that they are. So first thing we want to do before we start proofs is over on the back, we want to review just a few things that we already know about proofs, things that we've already learned, but that sometimes we could use a refresher on. So the first property that we want to review is the reflexive property. Now, one other thing that I'm not necessarily going to write, but you might if you would like to, you can have the reflexive property of congruence and you can have the reflexive property of equality, and they are 100% the same thing, except that one has a congruent symbol and one has an equal symbol in the line. So the reflexive property of equality would be referring to a line that has an equal sign in it. The reflexive property of congruence would be referring to a line that has a congruent symbol in it. But either way, the reflexive property uses exactly the same thing on each side of the equal sign or the congruent sign. Did it not print?
No.
Okay.
Did you hit print?
I thought I did.
I've been thumbing through papers that were all stacked on the print. I don't know, maybe somebody else printed over top of it or something.
I thought I printed. Actually, let me not. Let me freeze that.
I don't want to pull that one up today.
Let's try it again.
All 3 pages.
Mm-hmm. Okay, so it should be.
It went.
Yeah, well, it said it was going and then it disappeared. So let's make us an example line to do the reflexive property. So this would be a line in a proof. Your proof is typically going to be done as a table. And, oh, it's frozen. Sorry. There we go. How about now? So we're going to make just a little sample part of a table for a proof. The line over here on the left, this would be our statement. Our statement might be something like MP is congruent to MP. And wherever you have exactly the same thing on both sides of your equal sign, the reason that you can say that is by the reflexive property of, in this case, congruence. If there had been an equal sign there, we would have said reflexive property of equality, tomato, tomato, just match up the sign with the complete name. But that's the reflexive property. The one that sometimes gets confused for reflexive is the symmetric property. And now that we have talked about lines of symmetry and things like that, I hope that maybe this one will stick a little bit better on the review. The symmetric property is symmetrical. And it is symmetrical across that congruence or equal sign. Symmetric property is symmetrical. So on our example for that, let's draw ourselves another little sort of a proof. I'll probably need to extend that. So I'm going to use the same starting letters, M and P. But instead of saying MP again, I'm going to say PM. MP is congruent to PM. And this would be the symmetric property of congruence, because we used a congruent symbol over here instead of an equal sign. If it had been an equal sign, this would be the property of equality. And so you might be wondering, well, if they're the same thing, right? Line MP and line PM are the same thing. So how do I know when to use the reflexive property? There you go. Okay. And when to use the symmetric. And it all has to do with those triangle congruences that we've talked about for the last couple of weeks. if you have triangles that have congruent statements, the matching parts have to go in matching order. So the matching order might be MP and MP, or it might be MP and PM, just based on the individual shapes. All right, so then we have substitution. Now, substitution doesn't have property of equality or property of congruence next to it. It's just plain old substitution. And substitution is a one-for-one swap. It uses two lines in a proof. And usually you're going to be swapping out either a name for a value. Let's put that. We'll often switch or swap, whatever, a name for a value or expression. But it might also swap out one name for another name. So for example, if you had two different angles that were congruent with each other and you just swapped them out one for one, that would still be substitution. So these are kind of in order of importance, which clues are the best. If it's a one-for-one swap, that's the best clue about substitution. To kind of verify that, it's going to often use two lines. And then this one is just kind of a like, oh, well, if you need some extra clues, it's often going to switch out a name for an expression, because that's not by definition what substitution is. It's just how it gets used. So an example of that, we're going to need two lines of our proof, right? Because it says uses two lines. So I'm going to draw a line here. I'm going to draw a line here. So on this proof, let's have angle A plus angle B equals 90. And we're just going to put a little scribble out here because we don't really know where that came from. We're just kind of making up an example. It could be because A and B are complementary, in which case this little scribble would say definition of complementary. It could be that it's given, and so you could have given out here. I mean, it could be a lot of different things. Bless you. They could even be like additive property of angles, angle addition. So this next line down here, let's say that angle A has a value of 2x and angle B has a value of 3x. Well, when we go from saying A plus B equals 90, and we say instead 2x plus 3x equals 90, we did a one-for-one swap. We swapped out angle A for 2x. We swapped out angle B for 3x. It's an even trade. So this is substitution. And if you want to put it out here, you did substitution twice, but that's okay. As long as you did the same thing in the line, you can do substitution 2 or 3 times, but it's all still substitution. And then after substitution, the one that's kind of similar to that is transitive property. So transitive property is like substitution, but a little more involved. Transitive property has 3 pieces, which are all going to be congruent, or they're all going to be equal to each other. It is going to use 3 lines. Whereas substitution only used 2. And in the last line, there's going to be some kind of a link that drops out or disappears. So we're going to say in the third line, a link drops out. So on this example, we're going to need, obviously, 3 lines. So there's line 1 There's line 2. There's line 3. I'm going to divide it up. Now, the first couple I'm just going to make up, right? Because we don't have a figure. We don't actually have givens. We're just going to set up this random sort of problem. So let's say that angle X is congruent to angle Y for some unknown reason. Maybe they're vertical angles. It could be vertical. It could be given. It could be that they're alternate interior. It could be definition of bisector. Well, it could be anything. That one's not important to this example. Then let's have angle X congruent to angle Z. And that would need some kind of reason also. Depending on the figure, the reason would vary. Maybe X and Z are corresponding angles or something. We don't know. And it doesn't really matter yet. This last line is the one that matters. Because X is congruent to Y, and X is congruent to Z, X is this little link. So Y and Z are congruent to each other. Angle Y is congruent to angle Z. That's a Y, by the way. My tail kind of crossed over. There we go. By the transitive property of congruence. And it's congruence because we used a congruent sign. It could have been equals if we had used an equal sign. It could have been transitive property of equality if we had used an equal sign. But the important thing is the pattern. You had X and Y that were congruent, and then X and Z that were congruent. And because both of these in this third line had X in common, X is like the link. And it's done its job in these two lines of linking up Y and Z so that we now know Y and Z are equal or congruent. So those are all review. We've been talking about those since August or September, but it's just been a while. So I wanted to go back over them with you. There are others, angle, segment and angle addition properties and segment and angle bisectors and all of that stuff. That's all still around. It's just that these are the ones that tend to need the most review. Then we have two more that we're going to add. These are new. So the first one, side, 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 or side, angle, side, or angle, side, angle, or angle, angle, side, or hypotenuse leg. And that's the end, I promise. Those are your triangle congruence postulates. Your triangle congruence patterns, as the name would indicate, are used to prove triangles congruent. Are used to prove two triangles are congruent. So let's use an example. This is only going to need one line. And we're going to put a couple little notes like out here and out here. So over here, we need to have some kind of triangle congruence statement. So such as triangle JKL is congruent to triangle FGH. So we're going to put over here, must have, and I did that in all caps for emphasis, must have a triangle congruence statement. That's the only time you're going to use these congruence postulates, is when the left-hand side is a set of congruence patterns. And then on the right-hand side, I'm just going to put one because we don't have the figure to let us know what has been marked. We're going to say choose the pattern based on all previous lines of the proof. It's not what's on the picture necessarily, it's what has been listed in the proof. What I recommend you do is you take the stuff from the proof and put it on the picture so that you can see it a little better. So that might involve sketching out the pictures that are on your computer screen and just marking from the previous lines of the proof what all you have. Just like we kind of saw last week, your brain goes ahead and assumes that some of these triangles are congruent. And so sometimes your brain is like, oh, this part's going to match this part. And eventually you might be right. But first you have to prove that those triangles are congruent based on previous information. So if you don't use the correct previous information, you could possibly miss this line when really it ought to be fairly simple.
Alyssa Johnson, come to the guidance office, please. Alyssa Johnson, come to guidance.
And our last one, our last line is CPCFC or CPCTC. It's been a couple weeks since we talked about this, but we have still been working with it. Corresponding parts of congruent figures are congruent, is what that stands for. If you want to write that down, I'm going to say it again over here. Corresponding parts of congruent triangles are congruent. Okay, corresponding parts of congruent figures are congruent, or corresponding parts of congruent triangles are congruent. Now, we're not going to really split hairs over whether to use CPCFC or CPCTC, although you can probably figure out that when you're talking about triangles, this one with the T for triangles, probably your more accurate answer. But if you say CPCFC, you're still going to get credit for that. We're not going to be that picky about which one you use. CPCFC is just a bigger category because F stands for figures and a triangle is a kind of figure. Now, in a proof, this is only used after the triangles are congruent. So we're going to say only used after, and I put all caps for emphasis, two triangles are proven congruent, just like up here. It's usually used to match up other parts that don't have a different reason, like maybe some angles where you can't call them vertical, you can't call them alternate interior, you can't do something like that. It's used after two triangles are proven congruent. Sets corresponding parts congruent to each other. Not equals in this case. It's not corresponding parts of congruent figures are equal. It's corresponding parts of congruent figures are congruent. So you've got to have the congruent sign there. But pretty much it could be right up here. So I'm just actually going to use this example from earlier because I kind of ran out of room. And it's supposed to follow this anyway, right? So if I already have the triangle congruent statement, remember from earlier, you can just use the order of those letters to match up matching parts. So let's say maybe JL. JL, first letter, last letter, should be congruent to what? First letter, last letter. So FH. After I have proven the triangles congruent, when I continue to match up their parts, my reason is CPCTC. I use T because it's triangles. You could put F and you'd still be okay. But the important thing again is this goes after triangles are congruent. It cannot go before. So on the front side of that sheet, we're going to do a couple of proofs together. And we're going to go ahead and do the crossword as well, just to kind of give us some hints and clues as we go. So if you'll remember back from proofs when we first started, you really want to start with this given. And if you have a diagram, you want to make sure that your given information gets copied onto your diagram. So over here, we start with LM is congruent to NM. So I'm going to find LM, and there it is. And it's congruent to NM. So there's NM, just like that. It's maybe not my neatest markings, but it'll do. We also have MO bisects angle M. Let's find MO and let's find angle M and make some marks there. Here's MO, it goes right down the middle, and it bisects angle M, which is going to be up here at the top. So if it bisects it, that means it cuts it into 2 equal halves, just like that. So now all of my information that was written is on my diagram, and my brain's going to process it a little bit easier because of that. We're trying to prove that O is the midpoint. We can't mark that yet. Because remember, you can prove something true, you can prove it false. We have to get there before we know. So on statement number 1, what should our reason always be on this first line? Good, very good, given. So reason number 1 should always be given, and you'll notice that this is number 1 across on our crossword. So down here. You can't build on anything that wasn't given to you. So given is how we start. So then we have line 2. Something is congruent to angle NMO. So let's look. NMO starts on the outside, goes up to the top, and then goes down that line that is shared. That's going to be congruent to LMO. They go from the outside edge up to the top and then down the center. So LMO goes right there. And you're looking for the definition of something. Well, how do we know that those 2 angles are congruent? It's because MO is an angle bisector. That's what we had right here. MO bisects angle M. So the definition of angle bisector is what lets us know that these 2 angles are congruent. That's a B, by the way. Let's go fill in our crossword. So 2 across is LMO. It's right here. And then 3 across is angle bisector. ANGLE. It's not an angel bisector. It's going to mess up this box of other words if you misspell that. All right. Line 3. Halfway through the proof. MO is congruent to something. Well, just like we did up here, we want our parts to go in matching order. And so if we're reading our triangle going up like this and up like this, and then it's going to go down for MO, we're going to have another MO because that's going to be our corresponding parts. These triangles are like a reflection of each other. So MO, top to bottom, is going to be top to bottom on both triangles. So MO and MO. So from the back of your sheet, what property is exactly the same on both sides? Reflexive or symmetric? Good. Reflexive. Refers to itself like a reflexive pronoun. So number 4 and number 5, MO and reflexive. 4 across is right here. 5 across is above it. All right, line 4 of our proof. On line 4 of our proof, we have 2 triangles that are congruent. Put you a star right there. This is one of our new things. We had 2 new things. We had the triangle congruence patterns, and we had CPCTC. This one, if you're proving triangles congruent, probably going to be a congruence pattern. So let's see which one it needs to be. LMO. Oops, you can't see what I'm drawing. I'm sorry. LMO. I'm separating them down here. And this is NMO. I'm drawing them separate, just like I told you to do last week, because it's easier to see your pattern if the pictures don't touch each other. I am going to use only information from this proof because that's all I can use. And I'm going to mark this information on these two diagrams. So LM is congruent to NM. MO bisects angle M, but then we've got LMO. LMO is congruent to NMO. Then we have MO is congruent to MO. Now then, now that it's separated, what kind of a pattern do we have there? Anybody want to take a stab at it? Let's talk about how we can narrow it down. Your options are side, 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 angle, side, angle, side, angle, 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 side, hypotenuse, leg. Good, side, angle, side. Let's talk about how we're going to narrow it down in case you're still kind of wondering. I don't have all three sides. I don't have anything about this. I don't have anything about this, so it's not that. I don't know that angle O is a right angle. Looks like it, but I don't know, and I cannot assume, so it can't be this. I have a side and an angle and a side. Two sides and one angle. This does not have the right combination of two sides and one angle. This does not have the right combination of two sides and one angle. So SAS it is. It's a sandwich pattern, which means all of your pieces touch just like they would in a good sandwich. This side carries right up into that angle, and that angle opens up and carries into that other side. So all the pieces touch. Side, angle, side for number 6. So 6 is over here. There's that. Okay. After we have proven the triangles are congruent, now we're talking about some extra matching parts. So after we've proven the triangle's congruent, we're saying that NO, going in this way, is going to be congruent to what? Yep. And what's the reason that we use to talk about parts after the triangles are congruent? Very good. This is one of our new ones also. CPCTC, CPCFC, whichever one makes you happy is fine with me as long as you remember it. Now, number 7 on our crossword is down there. Number 8, all the way over here, CPCTC. I like that they didn't have this blank used for another word because you can put FC there if you want to. So now then, we have proven that this line is congruent to this line. And they're saying O is the midpoint of LN. And they're saying that because we have an equal amount of space on either side. Well, that's just the definition of midpoint. You have a visual up here that says O's in the middle of this line, and then they're putting the word midpoint with it. And that's what a midpoint is. So for number 9, midpoint. Okay, so not too bad. Just take it one piece at a time. And honestly, your pieces don't even have to go in order. And that's kind of the point I want to make over here. Oh, let's put a star by this also. Sorry. Line 5 used one of our new ones as well. On this next one, I want to give you some time to think, and I want you to try to find at least 3 different blanks that you could fill in on your own. Okay, so I'm going to give you a few minutes to think. Feel free to flip it to the back of your page, mark other stuff. This means parallel, right? And so AB is parallel to ED. And then C is the midpoint of AE, means that this matches this. So that's all of your given information. So I'm going to be quiet for a little bit and let you try to come up with 3 of these blanks anywhere. Start with the easy ones. And we'll see what you got. So if you're still kind of struggling, remember you don't have to go in order. I would personally start with this one right here, because that should be the same word every time. That can be one of your three. The next thing I see where I could probably fill in a blank, and you probably could too, without even looking at a picture, is blank number 5. Alternate blank angles are congruent. I feel like I know that word, and you probably do too. And after you've got that word filled in, you could probably match up these angles because you just have corresponding parts in a corresponding order. If that's not a good one, then maybe go to this one. See what kind of angles these are, because that's just the name of those angles. So that's another option. Yes, ma'am. Okay. 4. Okay, we'll get there in just a second. All right, so number 1, what was number 1? Given, yeah, always going to be given. So number 1 down here, G-I-V-E-N. Yeah, and you can use these two as a clue. So check this one out for number 4 down, right? Because you've got the first letter and you've got the last letter. So it's got to be just one letter in between for the 2 matching triangles. Okay, so number 2, blank, absolutely no hints. Definition of blank. Not much of a hint there. It's really, really subtle. The only thing that we have so far that we could have a definition for that would really be helpful in any way is midpoint. Definition of midpoint. So let's see if that fits in our crossword, because we're going to use all of our clues. M-I-D-P-O-I-N-T. Yeah, that's going to be it. Okay, now I'm kind of modeling how you should be thinking through that. Because if you didn't really just know it, you could use this as a hint. So this will be definition of midpoint. And definition of midpoint is going to have 2 parts that are congruent to each other. Let's see what parts they are. Well, our midpoint is C. And we've got A, C, and E, C that are congruent. That's going to be our statement. I'm going to put it underneath. AC is congruent to EC. And that is number 2 down. So 2 down right here. AC, congruent symbol, EC. Okay. So remember, you don't have to go in order. So like right here, I would have done this before I did this one if I were a student and I were working it from scratch, because this was not a real good set of clues that you had here. You had to work for that one. But over here, alternate what? Yep. Alternate interior angles are congruent. So 5 down is interior. And we're kind of working backwards whenever we put the reason and then we go make the answers anyway, right? So the statement, EDC, let's look at what we've got. Oh, sorry, we need to mark our alternate interiors with EDC. So up from E up to D down to C. And then we're looking for an alternate interior angle with that. Well, alternate interior angles need parallel lines and a transversal. So let me mark some parallel lines for us. I'm going to extend them just a bit. Oops. And there's our transversal. It's wavy, but you get the idea. So this bottom of this angle is going to be alternate interior with what? Angle A, angle B, angle C, angle E. Angle B, yeah. Very good. Angle ABC. It's that one right there. It's the bottom of this line and the top of this one. So angle A, B, C, because the order has to match E, D, C. So A, D, C. And then we're going to fill in that D right there. Next, we've got these 2 angles. They're named for us. And then we just provide their name for number 6. So ACB, there to there to there. So I'm going to put 2 little bumps in that. ECD, E to C to D, bump, bump. What kind of angles are those? Very good. V to V on 2 straight lines. These are vertical angles. VERTICAL fits in our blank. So that must be right. And here we are again. We have 2 triangles that are congruent to each other. We have to put matching parts in matching order. So if our first order is ACB, 0 marks, 1 mark, 2 marks in the angles, what order from the other triangle is going to match that? 0 marks to 1 mark to 2 marks in the angles. Oh, I'm sorry, I did it backwards. ACB. 0 marks to 2 marks to 1 mark. Sorry, now do it. ACB is going to match 0 marks to 2 mark to 1 mark. ECB. D. ECD. Why can I not talk? Sorry. So again, you're putting matching parts in matching order. And the way we would determine which parts match is by their markings. Angle B matches angle D because of their markings. Angle C on the left matches angle C on the right because of their markings. A is not marked and B is not marked, and they're the only ones not marked. So they have to match each other as well. So now we're looking for our congruence pattern. So I'm just going to take one of these and draw it kind of down here, clean it up a bit. We've already got our marks that we need, but I'm going to do it from the proof just to show you that that's what happens. So AC is congruent to EC. Here's AC. Angle ADC and EDC. Did I do that right? ABC. I'm sorry, you guys. There we go. So this one, I marked it right up here, but then I wrote D as in dog instead of B as in boy. So don't be like me. Then we have these vertical angles like that. So what pattern would that be? Very good. Shortest path goes like that. Angle, angle, side. It has 2 angles and 1 side. So your options are that or the sandwich. And the sandwich shouldn't have any gaps, but we got a gap right there. So sandwich is out. Angle, angle, side. Then we have, oh, I forgot to put 7 was ECD. And then number 9. So this is angle, angle, side. AAC, AAS. Oh my goodness. Okay, I can't English today. After we have proven the triangle's congruent, then we continue talking about their matching parts. There's a big long string of letters that goes over here. What are they?
CPCTC.
Yeah. Yep, either one. And again, it doesn't matter because your crossword doesn't connect right there. So CPCFC, CPCTC. I'm going to put T because we are talking about triangles, but if you put F, you're also correct. And there's that. So let me just preview your IXL assignments. You have 2 of them. They're for today and tomorrow. Your IXLs, maybe, there we go. Right there. Okay, so you got proving triangles congruent, proofs involving corresponding parts of congruent triangles. Now, to me, makes sense to do this one first because you can't talk about CPCTC stuff until you have proven the triangles congruent. Do you have to do them in that order? No, That's fine if you don't. But to me, it's how it makes the most sense. Now, you will have options. The higher you go in the levels, the more options you have for filling these in. So just use your good common sense, right? I've got 2 triangles that are congruent. There are 2 of these in this list that I cannot use. So this one and this one. Because when we're proving 2 triangles congruent, it has to be one of those letter patterns, the AAS, ASA, SAS, SSS, possibly hypotenuse leg, but it's not listed. The way you're going to determine which of those 4 it is by looking at whatever is marked. So you would take, let me see if I can, I'm going to try to be real extra over here and show you 2 screens at a time. And just going from how the rest of today has been, I don't know if it's going to work, but we're going to try it. All right. So what you're going to do is start right there. That'll keep me focused in one spot so I can hopefully make sure you see it. So I'm going to sketch. Doesn't have to be beautiful. I'm going to sketch. Y'all know my sketches are never beautiful. There we go. Okay, I've got this angle and this angle that are marked. And then I'm just gonna roll through here and mark stuff that I'm told. Let me put these letters on here, that'll help. Y, U, W, X, V. All right, triangle U, W, Y is equilateral. U, W, Y is equilateral. Now, equilateral means all the sides are the same. So I marked them. Angle VUW, VUW is congruent to angle WYX. WYX. Already had those as well. Angle XWY, here's XWY, is congruent to UWV. UWV. Bump, bump. Then we have these 2, WY, which is right there already marked, UW, right there already marked, and then we make our statement. So what we're using this angle, we're using this side, we're using this angle, right? Because I just want to look at one triangle at a time. Possibly this one over here as well, but it should have matching stuff. So what congruence pattern is that? They're all in a row, so it's a sandwich. Is it angle, side, or is it side, angle, side? Okay, thank you. Angle, side, angle. So ASA, and that's all you do every time. For triangle congruence, you just look and see what you already had. Now, sometimes that line might be filled in for you, but here in the beginning, it will not be. Let me also talk to you about these in here. The additive property of angle measure, additive property of, I think segment length is the other one. They use that a lot, and sometimes they use these with transitive property, just like they did here. So let's talk about how that happened. We said this angle equals this one plus this one. If it's the additive property, it's 2 smaller pieces of one big angle. Big angle equals the 2 small pieces. Then they substituted something. Let's see what they substituted. Line 6 most closely resembles line 4, in my opinion. You have USW, that's a match with line 4. USV, that's a match with line 4. Then they took VSW and switched it out for TSU because line 2 said you could do that. Then, because you had USV and TSU in line 5 and line 6, those 2 are the link. They link up USW and TSV. And so down here, USW and TSV are equal because of the transitive property of equality, just coming from that little equal sign. Okay, so I should have zoomed that in. Don't let all of those be super confusing. If you have questions about them, I will be glad to come work through them with you, and we will get that kind of taken care of. I feel like once you do a couple, you'll see this pattern in here a lot, where they switch up the this plus that for another this plus that. Okay, and honestly, your next one is exactly the same. They just keep going after you have proven the triangle's congruent. This will be the ones where you see the triangle congruence patterns already given sometimes. Maybe. There it goes. So see, you've got your triangle congruence pattern in line 4 and it's already given. And so after you've proven the triangle's congruent, that's the only thing you ever use. After you prove the triangle's congruent, and then you continue talking about the parts. All right, I'm gonna go ahead and end our Zoom. And you guys, folks at home, feel free to email me questions or set up a Zoom session if you need to do that.